The Mendocino Triple Junction is located at a place where the Gorda Plate, North American Plate, and Pacific Plate meet. This is one of the most seismically active regions in the US, and more than 10 magnitude larger than 6 events occurred in the past 40 years. Tectonic movements leads to high background seismicity rate. However, the productivity of earthquake clusters in this region is very low, meaning that relatively few aftershocks are observed within any given aftershock sequence. Here we analyzed the earthquake triggering process near the Mendocino Triple Junction by combining the cluster analysis with the characterization of tectonic stress field. We applied the nearest neighbor approach to investigate the spatial temporal features of earthquake clusters, and we used the MSAT algorithm to examine the stress field orientations and R values in the Mendocino transform fault, MTF, Gorda Slab, GS, and Northern San Andreas fault, NSAF. In these figures, it's shown by the green, red, and blue dots respectively. The nearest neighbor analysis of seismicity distinguishes the background and cluster mode based on the two-dimensional joint distribution of the rescue time and rescue distance between offspring and parents, which is shown by the black line here. And from the results, we can see that the background mode in the three regions are all stronger than the cluster mode. The nearest neighbor diagram results are corresponding to the low aftershock productivity in these three regions. The aftershock productivity A is defined as the exponent quantifying the scaling between the number of aftershocks and the magnitude of main shocks of clusters. The A value varies from A equals to 0.38 for the NSAF to 0.27 for the MTF and 0.25 for the GS. These values are all much lower than the Northern and Southern California productivity, which are A equals to 0.72 and 0.86 respectively. Also, from the distribution of cluster event counts and the longitude, we can see that the cluster event number increases at the triple junction. And one interesting fact is that in the NTF and GS region, which are mostly oceanic plates, the cluster properties are stable with time. Most clusters are spatially confined and do not extend across different plates, except for the 1992 magnitude 7.2 event. More details are shown in the poster. And these figures are the results for stress inversion. From the left to right are R values plus the tectonic styles, and the maximum horizontal shear stress SH max respectively. And we can see that the stress region is the most compressive at the triple junction. The maximum horizontal shear stress orientation, SH max, from an angle of 30 to 40 degrees with the fault structures in the Northern San Andreas fault system, suggesting that the faults are optimally oriented for failure. The SH max orientations are variable around the boundary between the MTF and the GS region. The continuing study can provide additional insights into the tectonic region, dynamics of earthquakes, and seismic hazards in the Mendocino Triple Junction.